Okay, geometry. Welcome to Chapter 12, Section 5, Angle Relationships in Circles. Pause, come back, and check your work. And so identifying each line or segment that intersects circle F, we have chords AE and CD. We have secant AE. We have tangent AB. And the measure of angle NMP is 110. It is a central angle, and here's the measure of the arc, right? And then we have measure of NLP, and LP is an inscribed angle with that same arc, so it would be half of that, right? Which is 55 degrees. Today we're going to find the measures of angles formed by lines that intersect circles and use angle measures to solve problems. So, our first theorem, if a tangent and a secant, or a chord, intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of its inscribed arc. Okay, so tangent BC and secant BA intersect at B. So the angle ABC equals half of the measure of arc AB. So this is just like the inscribed angle, isn't it? This is a little different because this ray is not interior to the circle. Let's find the measure of angle EFH. EFH. So here we have a tangent and a chord, and the angle of the arc formed by FH is 130. So what is the measure of angle EFH? Half of that arc. And so we should have half of 130, or 65 degrees. Okay, can we find the measure of arc GF? Arc GF. Well, this is interesting. So arc GF, we know that this tangent has this chord coming off of it here, and we have 122 degrees on this angle out here, exterior to the angle we're looking for, right? Or we might be looking for, because this angle FG and out here, right, is containing this arc FG. So if this is 122 degrees out here, we have a linear pair. How many degrees is this angle here? Good, 58, right? 58. And so we have 58 degrees is half of that arc. So what will we do? Multiply by 2, right? Multiply both sides by 2, and we should have 116 degrees is the measure of arc GF. So 58 would be half of that. Good. Can you find the measure of STU? All right. Don't forget to pause, come back when you're ready. And we have this arc ST, 166, so you know that this angle STU is going to be half of that, right? And so we can substitute our known values. Half of 166 is 83 degrees. Our next theorem says, if two secants, or chords, intersect in the interior of a circle, then the measure of each angle formed is half the sum of the measures of the intercepted arcs. So as we look here, angle 1 is formed by these intersecting lines. So the angle over here, opposite 1, is a vertical angle, right? So these angles are congruent. And these angles then are both half of the sum of AB plus CD. Those are the two intercepted arcs for these chords. And so that's kind of interesting. We add the 2 and take half. So let's find the measure of AEB. AEB. Okay, so AEB is formed by these intersecting secants, AC and DB. And so AEB has this arc AB, and opposite it is the arc DC, right? So we're going to add those arcs and then take half of their sum. So 139 plus 113 gives us 252, and half of 252 is 126 degrees. Again, this is called, well, there's not a fancy name, but we have two secants, and we're just taking the sum of their intercepted arcs and dividing by 2. Pause, find this, and come back. So the measure of angle ABD is half of the sum of the intercepted arcs of these, the secant and chord. So we have half of 37 plus 65. And 37 plus 65 is 102. Half of that is 51 degrees. RNM, find that angle. See what you can do. It's a little bit more challenging this time. And then come on back. All right, so there's more than one way we could approach this, but we'll follow what the text suggests, and that is we can find angle MNQ or RNP given this information. We simply can take half of the sum of the known intercepted arcs, MQ and RP. So when we take half of the sum, we get 158. So we know that this is 158, MNQ. So to find R and M, we see that these two angles form a linear pair, right? So 158 plus our missing angle equals 180, right? Or we just subtract the known angle from 180, and that gives us 22 degrees. So R and M is a 22-degree angle, as is Q and P. If a tangent and a secant, so here we have a tangent and a secant, or two tangents, or two secants intersect the exterior of a circle, then the measure of the angle formed out here, angle 1 or angle 2 or angle 3, is half the difference of their intercepted arcs. So we are not going to add these arcs. When you have an exterior vertex, rather than adding the measure of the arcs and dividing by 2, instead we subtract the measure of the arcs and divide by 2. We take the larger arc, subtract the smaller, and then multiply by half. Again, over here we would take the larger arc, EHG, major arc, and we would subtract the minor, EG, and divide by 2 to get this exterior angle. And over here we would take the arc JN, subtract arc KM, and divide by 2, or multiply by 1/2. Okay, so when you have an interior angle, you add the intercepted angles. Like in this case, we add them and divide by 2. But when we have an exterior angle, we subtract and divide by 2. So let's try this. Find the value of X, this little angle DEF in here. Okay? So using what we just saw, we're going to take 87 degrees, subtract 7, and divide by 2. Because X equals half of major arc minus smaller. So half of 87 minus 7 is 40 degrees. Try this and come on back. And you should have half of arc AD minus arc BD, and that would be half of 200 minus 74, which is 63 degrees. So how about if we know the angle, the exterior angle here formed by the two secants, and we are trying to find the missing arc, KM. So we're going to use our same formula, right? We know that 25 degrees is equal to half of the known arc JN minus our unknown X, right? When we substitute, we now just solve for X. So we could just multiply both sides by 2 here to get that half out of here. And now we will add X and subtract 50, giving us 33 degrees. Very fun. It's kind of fun to see a different way of looking at this, right? In the company logo shown, the measure of arc FH is 108. and the measure of arc LJ is 12 degrees. So what is the measure of FKH? So we're looking at the angle that has a vertex exterior to the circle with two secants, right? So once again, we have the measure of this angle equals half of the difference of the major arc and this minor arc here. So let's substitute our known values. Half of 108 minus 12. And so you should have 48 degrees. And this is the final important facts that you need to know. Angle relationships in circles. So when we have a vertex on a circle, this is kind of just summing it up, isn't it? We know that that angle is half of the intercepted arc. This is an inscribed angle. When we have a vertex inside the circle, we take half of the sum of the measures of its intercepted arcs. And when we have the vertex outside the circle, we take half of the difference of its intercepted arcs. So just a beautiful summary of what we have been working with the last couple days and today. So we can use this in a diagram with more going on. Find the measure of YZ. So the first thing we're asked to do is find the measure of arc UY. Arc UY. Well, we can use this angle XVY to help us find UY. And XVY is something we know we can find because we have this given angle 113. And this angle 113 forms a linear pair with XVY, right? So XVY would just simply be 180 minus 113. And we're going to use that because we know that this arc, WZ, and if we have this angle, we know that if a tangent and a secant intersect at a point of tangency, which is what these two are doing, these two here are doing, then the measure of the angle formed is half the measure of the intercepted arc, right? So we know 180 minus 113, which is 134, is half of UY plus the measure of WZ. And so we can use this to find the measure of UY by just subtracting. We have 66 degrees. 66 degrees. But the question is, what is YZ? Well, this is 66. Okay, so again, YZ, this arc out here, is related to UY, and that XY and XZ are meeting at this point out here, this vertex exterior. So this tangent and this secant are meeting out here, and we have this minor arc here and a major arc there. So using what we just learned, we know that 49 would be half of the difference of the major minus the measure of UY. And we just found UY, so we can use that information to find YZ. So angle X is 49, so we're going to substitute 49. And YZ is unknown, but we have UY, which is 66 degrees. So now we simply have one unknown, the measure that we're looking for. So we could start right now by multiplying both sides by 2, and that gives us 98. 98 equals this large arc minus 66. So add 66 to both sides, and the measure of YZ is 164 degrees. Okay, pause, come back and check. And the measure of angle FGJ and HJK. And can you find X? And X is 30 degrees. There you go. Have a good day.